So the relatively destructive reaction of alkenes are actually synthetically quite useful. And among them, the most important one is oxidative cleavage of alkenes, which destroys an alkene and cleaves the carbon chain at the point where the double bond used to be. This reaction can be performed with potassium permanganate. The difference between these reaction conditions and those used for dihydroxylation, potassium permanganate has to be concentrated or hot in this case. And once we expose this to the following conditions, we will get a mixture of various oxidation products, such as these acids, etc., which will, but all of them will share a common feature that the double bond is broken. However, to do this in a more predictable fashion, there is a better method known as ozonolysis. And ozonolysis, as its name implies, uses ozone, which is the unstable form of oxygen, O3. And the resonance structures of ozone have a dipole in them, so this would be one of them. And the alternative would be the one which has the terminal carbon switched, so the central still has a plus charge, and their distribution of charge. And this is ozone. Now, ozone, you probably hear a lot about it. Exists in top layers of atmosphere where it protects us from UV rays, but on Earth's surface, actually, it's quite harmful because of its high reactivity. And so when exposed to the ozone, an alkene will initially form a so-called ozonide, which is this species with a 5-membered ring which has 3 oxygens and 2 carbons. And exposure of this ozonide to reducing agents such as dimethyl sulfide will give us two carbonyl compounds, in this case a ketone and an aldehyde. And the carbonyl groups are now in positions with a double bond used. And the mechanism of this reaction is a little tricky, but it still can be rationalized. So if we have initially the nucleophilic oxygen in ozone will attack the alkene, and we'll get a back attack here, finally resulting in a compound which is called mol ozonide, and it's unstable. And then collapse of this mol ozonide involves generation of one carbonyl compound and an oxidized version of another carbonyl compound. And now this rearrangement involves a nucleophilic attack here and here to give us finally the ozonide. We're not going to go into the mechanism of reduction of the ozonide, but suffice it to say that we need to introduce a reducing agent to take care of this extra oxygen. So this is dimethyl sulfide, which then eliminates dimethyl sulfoxide as a product, giving us two carbonyl compounds as the final outcome. Yep. This is an incredibly useful reaction because it allows us to get carbonyl compounds. In this case, we get two carbonyl compounds. If in cases of cyclic alkenes, we will get one dicarbonyl compound, such as in this example. This will be a CHO, and this will be a CHO. So this will be a dialdehyde. And so forth. And so this is perhaps not most straightforward reaction synthetically, because we often think about synthesis in terms of making bonds, and this is really a breaking a bond. But it could oftentimes be an interesting roundabout way to get a carbonyl compound through an alkene, which is then cleaved and Oxiditive. So in summary, there are two methods that we're going to use for cleavage of oxidative cleavage of alkenes: the potassium permanganate method and the Ozonide method. And the ozonolysis works more predictably, so it should be used more frequently.